So we want to get better information about the partitioning details. All right. First, let's do that straightforward way for the partitioning step. So based on our intuition, we can easily do in this way, but it may not be the best way. Yeah. So let's start with an array, and we use the last element as the pivot. All right. Then we scan the whole array from the first one to the last one before this pivot. Okay? All right. So when we scan, basically we have two cases. The first one, value of the current array element less than or equal to p. The other case, greater than p. So when we have that information, so we can arrange these elements in two different auxiliary arrays. Yeah. That's our first try. Yeah. First try, so we're allowed to get some, use some redundancy. Yeah. All right, suppose let's have two empty arrays ready for new elements to be assigned in these two subarrays. All right, arrays. All right. For the first case, a of I less than or equal to p, let us pack it in the first auxiliary array. Okay. Yeah, so we pack one by one, so eventually we get a whole array, all the elements in that array less than or equal to p. Okay. Similarly, for the case that the array value greater than p, so let's put in a second array, one after another, until we get all the elements that are greater than p. All right. After that, then we copy back to A array. Make simple copy back to A array, and we get a partition. After that, we get a partition. But the question is, are we satisfied with this solution? Yeah. So you can see something we may not do the best, something we can save more. Yeah. So let's try to look at that. Okay. Examine auxiliary array-based solution. Here you can see we use extra amount of space other than the performance factor. So here, for the performance comparisons, so it looks okay, but the storage space, we also need to consider that factor. Another important factor we need to consider. Okay. How much extra storage space is used? We use two auxiliary arrays. The total number of locations assigned to those two arrays, auxiliary arrays, that's the extra space we need to pay. Okay? So by the auxiliary array, yeah, so suppose the data size k, so we need this much space, extra space. The more memory resource is used, the slower the performance. For the whole application, if we use too much space, then we slow down that application. All right. So here we can use a typical situation, web server. we run some web application in a web server. Usually there are many users access that web server concurrently. If your application is not very efficient, for each user you use a little more extra space, more than necessary. Then for a large number of users, then you waste too much space, storage space. Then the performance of your whole web application will be slowed down a lot. Okay? Yeah. The question, can we do the partition without using the auxiliary array? Without auxiliary array, we do not need it. Okay? Yeah. It's possible, so we can make that happen. We need to control extra space used. Okay? Yeah. All right. Our goal, we want to save the space used for auxiliary arrays. So our goal, we want to get big O of 1 or big theta of 1 extra space. Okay? Yeah. Yeah. All right. But when we do that, so right now we need to work a little harder because we mainly use the original array for the storage space. We can use small number of extra space, but not too many. Okay? Yeah. All right. So when we process the elements in the array, remember we need to scan from the beginning to end. When we process the elements in the array, there are 3 cases for each array. The first one, an array is placed in A array, A subarray. Second case, placed in B subarray. Third case, unprocessed. We haven't processed. So there are some elements. So we use these 3 different status to characterize all the array elements. All right. Okay. All right. So now you can see here, in order to facilitate our discussion, we create a name for it. So S region. S here means smaller, smaller or equal to P. So we call it S region. Okay? Yeah, so for A array, it should go to S region. L region, larger, larger than the value, larger than P. So the B array should go to the L region. Okay? Unprocessed, U region, yeah, because we haven't processed these elements. So we create a U region for those elements. So you can see we use these 3 regions to manage all our array elements. All right. So for S region and L region, they're initially empty. Yeah. So when we start, they are empty. Yeah. All right. So then we grow these 2 regions. So we add element 1 by 1 into these 2 regions. Yeah. But for the U region, unprocessed, initially all the elements except the pivot, okay, all in that region. Then we reduce U region until it is empty. At the end, the U region is empty. Okay? All right. So that's our arrangement. So that's our plan. So when we work, we try to manage our data in a well-organized way. All right. The question is how to grow and how to grow the first two regions and reduce the last region. Okay. All right. So that detail, we leave it to part B.4.